Every fighter jet in Chinese Air Force service history. One of these fighter jets was built by sawing a secret Soviet prototype into pieces and reverse engineering the fragments in total defiance of Moscow. There are 9 primary fighter jet families in this nation's military history. This is every single one. In 1956, the Shenyang J-5 entered service as China's very first jet fighter, manufactured as a direct, licensed production model of the legendary Soviet MiG-17 Fresco. When the People's Liberation Army Air Force needed an interceptor capable of challenging American and Taiwanese reconnaissance missions during the height of the Taiwan Strait crises, Soviet engineers transferred thousands of blueprints to the newly built Shenyang aircraft factory to get production rolling overnight. Powered by a single Wopen 5 centrifugal flow turbojet, producing 7,450 pounds of thrust with afterburner, the J-5 could reach a maximum speed of 711 miles per hour while carrying 3 heavy-caliber nose cannons designed to rip through aluminum bomber fuselages. In my opinion, the J-5 is the single most important industrial milestone in modern Chinese history because it transformed a peasant agricultural economy into a jet engine manufacturing power in less than a decade. But while copying early Soviet designs provided a baseline for basic airspace defense, the rapidly accelerating speeds of the Cold War demanded a fighter that could smash through the sound barrier. In 1958, the Shenyang J-6 took flight as China's first mass-produced supersonic fighter, built as an indigenous clone of the Soviet MiG-19 Farmer. During the Vietnam War, Chinese-piloted J-6 interceptors scored multiple confirmed victories against American attack aircraft that strayed too close to the southern border, relying on astonishingly fast climb rates to ambush intruders from below. Driven by twin Wopen 6 axial flow turbojets, generating a combined 14,300 pounds of thrust, it achieved a top speed of 958 miles per hour, roughly Mach 1.3, while operating from unpaved, dispersed rural airfields. To me, the J-6 was a crude but brilliant instrument of territorial defense, a machine so mechanically reliable that hundreds of retired airframes have now been converted into unmanned combat drones aimed at the Pacific. Yet just as Shenyang mastered twin-engine supersonic assembly, a bitter ideological split between Beijing and Moscow severed all technical support, forcing Chinese engineers to pull off one of the most audacious espionage gambits in aviation history. In 1966, the Chengdu J-7 was introduced as a lightweight Mach 2 interceptor born out of the Sino-Soviet split and the wreckage of a single incomplete MiG-21 fishbed prototype. When Soviet Premier Nikita Khrushchev abruptly canceled technical aid in 1960, Chinese intelligence operatives reportedly managed to smuggle technical drawings and sample airframe components across the border, leaving engineers to reverse engineer the complex delta-wing geometry entirely by hand. Equipped with a Liang Wopen 7B afterburning turbojet producing 13,448 pounds of thrust, the J-7 hit speeds of Mach 2.05 while retaining the tiny, highly agile silhouette that made the fishbed family so lethal in close-quarters dogfights. If you ask me, the J-7 is the ultimate survivor of the Cold War aerospace industry, evolving through more than 50 upgraded variants over a 50-year production run that outlasted the Soviet Union itself. And speaking of 50-year legacies, if you are enjoying this breakdown of military aviation history, the next complete country lineup is already scripted and ready for production, so hit that subscribe button right now so you don't miss it. Now, while the lightweight J-7 excelled at short-range point defense, the PLA Air Force quickly realized they needed a high-altitude heavy interceptor capable of hunting American B-58 and B-70 supersonic bombers. In 1969, the Shenyang J-8 took to the sky as China's first locally designed twin-engine interceptor, earning the NATO reporting name Finback. Because domestic radar technology in the late 1960s was still lagging years behind the West, early J-8 variants were essentially stretched, twin-engine versions of the J-7 that relied entirely on ground control radar stations to guide them toward high-altitude targets. Powered by two Wopen 7A turbojets, generating over 21,000 pounds of combined afterburning thrust, the Finback could ascend to an operational ceiling of 66,000 feet at a top speed of Mach 2.2. My verdict on the J-8 is that it was an aerodynamic dinosaur that stayed in service far longer than it should have, serving as a painful reminder of the technological gap China faced during the Cultural Revolution. But as the 1980s gave way to modern beyond visual range missile warfare, Beijing recognized that raw high-altitude speed meant nothing without a modern multi-role strike radar, prompting a complete shift in tactical doctrine. In 1988, the Xi'an JH-7 Flying Leopard entered service as a two-seat, twin-engine maritime strike fighter, engineered to hunt enemy naval task forces in the South China Sea. Unlike traditional interceptors, the Flying Leopard was designed from day one around low altitude, high subsonic penetration, carrying heavy supersonic anti-ship cruise missiles under its wings, while flying just feet above the ocean waves to evade radar detection. Driven by twin Rolls-Royce Spey turbofans, which China acquired and licensed as the WS-9, it boasts a tactical combat radius of 1,090 miles and a heavy weapons payload exceeding 14,000 pounds. I believe the JH-7 is the most underrated aircraft in China's Cold War inventory, serving as the quiet, blue-water hammer that allowed the PLA Navy to project power beyond coastal defense long before their aircraft carrier program even existed. Yet maritime strike capability was only half the battle. To truly contest airspace with the West, China needed an air superiority heavyweight that could go toe-to-toe with the American F-15 Eagle. In 1998, the Shenyang J-11 was deployed as a fourth-generation air superiority heavy fighter, originally born from a multi-billion-dollar licensing deal to manufacture the Russian Su-27 flanker on Chinese soil. Within just a few years of production, Beijing abruptly terminated the Russian contract after claiming the aircraft didn't meet PLA requirements, only to turn around and produce an indigenous, virtually identical version equipped with Chinese avionics and radar systems that sparked a furious intellectual property dispute with Moscow. Powered by twin Shenyang WS-10 afterburning turbofans producing 29,000 pounds of thrust each, the J-11 reaches Mach 2.35 while pulling jaw-dropping 9G turns thanks to its blended wing-body aerodynamics. To me, the J-11 represents the exact tipping point where Chinese aerospace stopped merely importing Russian engineering and started aggressively superseding it. However, relying on foreign airframe geometry wasn't enough for national pride, which leads us to the most controversial delta-wing fighter of the 1990s. Also flying in 1998, the Chengdu J-10, known as the Vigorous Dragon, arrived as China's first truly indigenous fourth-generation multi-role tactical fighter. Western intelligence analysts immediately noted its striking aerodynamic resemblance to Israel's canceled Lavi fighter project, though Chinese designers insisted the Canard Delta configuration was an original development born from decades of high angle of attack wind tunnel testing. Equipped with an indigenous WS-10B thrust-vectoring turbofan engine pushing 32,000 pounds of thrust, the J-10 hits Mach 1.8 and features a fly-by-wire digital flight control system that makes it exceptionally unstable and agile in visual-range dogfights. In my view, the J-10 is the absolute workhorse of the modern PLA Air Force, a highly cost-effective multi-role platform that finally gave China a domestic answer to the American F-16 Fighting Falcon. Now ask yourself a question. When an Air Force masters both lightweight dogfighters and heavyweight interceptors, how do they bridge the gap to dominate modern electronic warfare? In 2012, the Shenyang J-16 Hidden Dragon entered service as an advanced fourth-generation plus heavy strike fighter, engineered for long-range offensive missions. Stripped of all traditional analog instruments, the rear cockpit of this two-seat fighter is a dedicated command module, where a weapons systems officer operates an active electronically scanned array radar, capable of jamming enemy air defenses while guiding multiple beyond visual range hypersonic missiles simultaneously. Powered by upgraded twin WS-10C turbofans producing over 32,000 pounds of thrust per engine, it carries a staggering 26,000-pound payload across a 930-mile combat radius without refueling. The J-16 is unquestionably the most dangerous non-stealth fighter in Asian skies today, acting as the heavily armed missile truck that supports lighter forward-deployed fighters. Which brings us to the question I want you to answer today. Looking at how China evolved from copying Soviet MiG-17s to building the electronic warfare J-16. Do you think reverse engineering accelerates innovation, or does it leave an aerospace industry permanently dependent on foreign concepts? Drop your answer in the comments below right now. But while the J-16 dominates conventional airspace, the 21st century demands an airframe that radar simply cannot see. In 2017, the Chengdu J-20 Mighty Dragon became operational as the world's third fifth-generation stealth fighter, permanently shattering the American monopoly on operational low-observable tactical aircraft. Featuring a unique, elongated Delta Canard configuration engineered for high-altitude supersonic cruising, the J-20 is built with internal weapon bays large enough to carry long-range PL-15 air-to-air missiles, designed to bypass enemy fighters and destroy critical airborne refueling tankers and radar-warning aircraft. Powered by twin WS-15 afterburning turbofans, generating a combined 80,000 pounds of thrust, it achieves speeds up to Mach 2.0 while maintaining a front aspect radar cross-section designed to blend seamlessly into background atmospheric noise. I believe the J-20 is the single most formidable strategic challenge facing Western air superiority today, because it proves China can design, build, and deploy a world-class stealth interceptor completely on its own terms. And that remarkable leap to fifth-generation stealth dominance is exactly why the aircraft I opened with, the smuggled MiG-21 fragment that became the Chengdu J-7, was such a desperate gamble for an isolated nation. If you want to see which country or manufacturer we uncover next, the script is already in production, so hit subscribe right now, and I'll see you in the next hangar.